Hello friends, now we have to evaluate this definite integral that is given by tan inverse alpha x multiplied by tan inverse beta x divided by x square between the limit 0 to infinity. So first we suppose that this integral is equal to I, that is tan inverse alpha x tan inverse beta x divided by x square. Now we suppose that this is first equation. Now here we can see that this alpha and beta both are independent from x. So these are called parameters. So first we differentiate this integral under the sign of integration. So first we differentiate here, differentiate with respect to the parameter alpha. Here we know that alpha and beta both are independent from x. So for evaluating this definite integral, first we differentiate under the sign of integration. Here we differentiate with respect to the parameter alpha because alpha is independent from x. So this can be written as di upon d alpha is equal to d by d alpha of the given integral tan inverse alpha x multiplied by tan inverse beta x divided by x square dx. Now you know that this d by d alpha when goes inside the integral sign, it converts partial differentiation. So this can be written as integral 0 to infinity del by del alpha of tan inverse alpha x multiplied by tan inverse beta x divided by x square. You know that when this d by d alpha goes inside the integral sign, this converts partially. Now here we have to differentiate this function partially with respect to the parameter alpha. So this x square is constant because here we have to differentiate with respect to parameter alpha. Tan inverse beta x, this is also constant. So we differentiate only here tan inverse alpha x with respect to alpha. So this can be written as differentiation of tan inverse x. We know that is 1 upon 1 plus x square. So differentiation of this is 1 upon 1 plus alpha square x square. And when we differentiate alpha x, we get x here because x is constant with respect to alpha. And in the numerator, this is tan inverse beta x, and in the denominator, this is x square. You can see here, we differentiate only tan inverse alpha x with respect to alpha. This tan inverse beta x is constant here because we have to differentiate partially with respect to alpha. So tan inverse beta x is constant here and x square is also constant. Now we differentiate tan inverse alpha x with respect to alpha, we get 1 upon 1 plus alpha square x square. Now we differentiate this alpha x with respect to alpha, we get x is constant and differentiation of alpha with respect to alpha, this is equal to 1. Now this is equal to di divided by d alpha. Now we can see here this tan inverse beta is also here. You can see here this beta is independent from x. So this is also a parameter. Now we again differentiate with respect to parameter meter beta. Now we differentiate again with respect to the parameter beta, because beta is independent from x. So this can be written as d by d beta of di upon d alpha. This is equal to d by d beta of 0 to infinity x tan inverse beta x divided by 1 plus alpha square x square multiplied by x square dx. You know that this d by d beta goes inside the integral sign. This converts partially. So this can be also written as del by del beta of x tan inverse beta x divided by 1 plus alpha square x square multiplied by x square dx. You can see here, when we differentiate partially with respect to beta, this 1 plus alpha square x square is constant here, this x square is constant, this x is constant. So we differentiate only tan inverse beta x with respect to beta. So we know that differentiation of tan inverse beta x can be written as here 1 plus alpha square x square, this is constant, and differentiation of tan inverse beta x is 1 upon 1 plus beta square x square, and this x square. Now this x is here, and we know that when we differentiate this beta x with respect to beta, we get x is constant, and differentiation of beta with respect to beta, this is 1, so this becomes x square. Now you can see here, this x square is cancelled by this x square. So this can be written as here, this x square is cancelled by this x square. So you can write this 1 upon 1 plus alpha square x square and 1 plus beta square x square here. So in the left hand side you can see that this is d2i by d beta d alpha. Now on the right hand side we can see the integration of 1 upon 1 plus alpha square multiplied by 1 plus beta square x square. So first we do partial fraction of 1 upon 1 plus alpha square x square multiplied by 1 plus beta square x square here. Now we do partial fraction of this 1 upon 1 plus alpha square multiplied by 1 upon 1 plus beta square x square. Now we do partial fraction of the 1 upon 1 plus alpha square x square multiplied by 1 plus beta square x square. So you can see here 1 upon 1 plus alpha square x square multiplied by 1 plus beta square x square. So put here x square is equal to y. This becomes 1 plus alpha square y multiplied by 1 plus beta square y. We suppose that here this can be written as a upon 1 plus alpha square y plus b upon 1 plus beta square y. Now we taking LCM on the right hand side, so we get here 1 plus alpha square y multiplied by 1 plus beta square y. Here a multiplied by 1 plus beta square y plus b multiplied by 1 plus alpha square y. In the left hand side we can see here this is 1 plus alpha square y and 1 plus beta square y. You can see that this term is cancelled out, so 1 is equal to a multiplied by 1 plus beta square y plus b multiplied by 1 plus alpha square y. Now we find the value of the unknown capital A and capital B. So put here 1 plus alpha square y is equal to 0. So y is equal to minus 1 upon alpha square. You can see here when we put here 1 is equal to a 1, here we put in place of y we put here minus 1 upon alpha square, so this becomes 1 minus beta square upon alpha square multiplied by y. So this can be written as alpha square divided by alpha square minus beta square, alpha square minus beta square. Here we put value of y, so this is minus 1 upon alpha square, so this is 1 minus beta square upon alpha square. When we take LCM here, we get alpha square minus beta square upon alpha square, so we multiply alpha square in the numerator in the left hand side and alpha square minus beta square in the denominator in the left hand side. So this becomes the value of a. So value of the unknown capital A is equal to alpha square divided by alpha square minus beta square. Now again we put 1 plus beta square y is equal to 0. So y is equal to minus 1 upon beta square. You can see here again we put 1 plus beta square y is equal to 0, and we get here y is equal to minus times 1 upon beta square. So when we put in above identity, we get here 1 is equal to, here this is 0 and this is b1. When we put minus 1 upon beta square here, this can be written as alpha square 1 minus alpha square upon beta square. So from here we can see that beta square upon beta square minus alpha square, this is equal to capital B. So these are the values of unknown capital A and capital B. You can see here capital A is here, alpha square upon alpha square minus beta square, and capital B can be written as beta square taking common minus here, so this can be written as b is equal to minus times beta square upon alpha square minus beta square. So these are the unknowns. Now we can see here the partial fraction. We can see here the partial fraction of 1 upon 1 plus alpha square x square multiplied by 1 plus beta square x square. This is equal to capital A. Here capital A is alpha square upon alpha square minus beta square multiplied by 1 plus alpha square y. Then in place of b we put here this beta square upon alpha square minus beta square multiplied by 1 plus alpha square y. Here we put value of y, so this becomes x square, and here is also x square. So this is the partial fraction of 1 upon 1 plus alpha square x square multiplied by 1 plus beta square x square. Now you can see here, so this is the partial fraction. Now we put this is in the integration in place of 1 upon 1 plus alpha square x square multiplied by 1 plus beta square x square. Now we put partial fraction of the inside the integral sign. So we get here d2i by d beta d alpha. This is equal to integration of 0 to infinity and alpha square divided by alpha square minus beta square multiplied by 1 plus alpha square x square minus beta square divided by alpha square minus beta square and 1 plus alpha square x square. So this is the partial fraction inside the integral sign 1 upon 1 plus alpha square x square multiplied by 1 plus beta square x square. You can see that this alpha square minus beta square and alpha square, this is constant, so it will be outside the integral sign. So this can be written as alpha square upon alpha square minus beta square, and 0 to infinity 1 upon 1 plus alpha square x square dx. Similarly here beta square upon alpha square minus beta square, this is also constant, so integrate here 1 upon 1 plus alpha square x square dx. You can see that in the this integral alpha square upon alpha square and beta square, this is constant, so it will be outside the integral sign, so we write here 1 upon 1 plus alpha square x square. And this beta square upon alpha square minus beta square, this is constant, so we write here 1 upon 1 plus alpha square x square. Now we integrate this 1 plus alpha square x square. Now we integrate this 1 plus alpha. Now we integrate the first integral. We know that the integral of this is alpha square upon alpha square as beta square here, and integration of this is 1 upon alpha tan inverse alpha x. And here you can see that integration of the second integral is here 1 upon beta tan inverse, here this is and this is 1 plus alpha square x square, and this is 1 plus beta square here. Now this is tan inverse beta x, you can see here. Here we integrate this integral of 1 upon 1 plus alpha square x square is 1 upon alpha tan inverse alpha x, and integration of 1 upon 1 plus beta square x square, this is 1 upon beta tan inverse beta x. Now we put here limit, upper limit infinity in place of x, then minus lower limit 0 in place of x. You can see that this alpha is cancelled by this square, so this is alpha upon alpha square minus beta square. Here we write in place of x infinity, so this becomes tan inverse infinity minus tan inverse 0 here. And here you can see this is beta square upon alpha square minus beta square, and you can see here this beta is cancelled by this square, so this is beta upon alpha square minus beta square, and tan inverse infinity minus tan inverse 0. Now we know that tan inverse infinity, this is pi by 2, and tan inverse 0, this is 0 here. So alpha upon alpha square minus beta square, this is pi by 2 minus 0, and this is beta upon alpha square minus beta square, and this is pi by 2 minus 0. So you can see here this is pi by 2, this is pi by 2 of alpha square minus beta square, alpha minus beta square. So we taking common here, so we get alpha minus beta divided by alpha square minus beta square multiplied by pi by 2. Now you can see here we factorize this alpha square minus beta square, so we get here pi by 2 alpha minus beta, and this alpha plus beta, alpha minus beta. You can see here this alpha minus beta is cancelled by this alpha minus beta, so we get here pi by 2 times alpha plus beta. This is d2i by d beta d alpha. Now we can see here this d2i by d beta d alpha, this is equal to pi upon 2 alpha plus beta. Now we integrate this with respect to beta. Integrate with respect to beta here. So this can be written as di by d alpha here, and pi by 2 is constant here, so 1 upon alpha plus d beta, alpha plus beta d beta, and c1 is the integration constant here. Now we integrate this 1 upon alpha plus beta with respect to beta. So we know that integration of this is log alpha plus beta here plus c1. This is di by d alpha. Suppose this is equation 4. Now we find value of integration constant c1. So for this we put beta is equal to 0 in di by d alpha is equal to 0 to infinity x tan inverse beta x divided by 1 plus alpha square x square multiplied by x square dx. Now put beta is equal to 0 in this. When we put here beta is equal to 0, so tan inverse 0 is 0, so di upon d alpha is equal to 0. You can see here. When we put beta is equal to 0 in second equation, that is n di by d alpha is equal to integration 0 to infinity x tan inverse beta upon 1 plus alpha square x square multiplied by x square. Here we put beta is equal to 0, so tan inverse 0, this is 0, so di alpha upon d alpha is 0. Now we put beta is equal to 0 in 4, so we get here di by d alpha is 0 here when beta is equal to 0, so we put here 0 is equal to pi by 2 and we put here beta is equal to 0, so we get alpha plus c1. So here c1 is equal to minus pi by 2 log alpha. So this is the value of integration constant c1, that is minus pi by 2 log alpha. So we put this in fourth equation. Put in 4 we get. Here we put value of integration constant c1. Now we put value of c1, that is value of integration constant in 4. We get here di divided by d alpha is equal to pi by 2 log of alpha plus beta minus pi by 2 log alpha. So you can see here this is di by d alpha is equal to pi by 2 times log alpha plus beta minus pi by 2 times log alpha. Now again we integrate with respect to alpha. So we get here this is equal to pi by 2 integration of log alpha plus beta with respect to alpha minus pi by 2 integration of log alpha with respect to alpha. Now again we integrate this. So in the left hand side, when we integrate di upon d alpha with respect to the parameter alpha, we get here I, and in the right hand side we integrate log alpha plus beta, then log alpha. So you can see here when we integrate this, we multiply here 1 and using here integration by parts. So we suppose this is the first function and this is the second function. So first function is log alpha plus beta, then integration of second function, that is integration of 1. So integration of 1 with respect to alpha is alpha here, minus differentiation of first function is 1 upon alpha plus beta, and integration of second function, that is integration of 1 with respect to alpha is alpha here. So this is d alpha minus, you can see here integration of log alpha. So here we multiply 1 Here we multiply 1 and use integration by parts. Suppose this is first function, this is second function. So first we write here first function log alpha, then integration of 1 is 1 with respect to alpha is alpha here, minus integration differentiation of first function. So differentiation of log alpha is 1 alpha here and integration of 1 is alpha here and d alpha. So you can see that this is the integration of log alpha, and here the integration log alpha plus beta. So you can see here this is pi by 2, here alpha log alpha plus beta. Here you can see that integration of this can be written as alpha plus beta minus beta divided by alpha plus beta. Here we add and subtract beta in the numerator, and you can see here this pi by 2 alpha log alpha minus alpha is cancelled out, so this is d alpha only. Now you can see here this is pi by 2 alpha log alpha plus beta minus, here you can see that this alpha plus beta divided by alpha plus beta, we get here 1 minus this minus beta upon alpha plus beta, and here we write this is d alpha. Now you can see here this is pi by 2 alpha log alpha, and here integration of d alpha is alpha. So here we can write pi by 2, taking common pi by 2, we get here alpha log of alpha plus beta here, and integration of 1 with respect to alpha, this is alpha here, this minus and minus plus here, and integration of beta upon alpha plus beta with respect to alpha, so beta is constant, and integration of 1 upon alpha plus beta with respect to alpha is log of alpha plus beta, and here we write minus multiplied by alpha log alpha, and this minus multiplied by minus, this is plus alpha here. So you can see here in the right hand side alpha is cancelled out here, this alpha is cancelled out, and I is equal to pi by 2. You can see here this log alpha plus beta is common here, so we write alpha plus beta multiplied by log of alpha plus beta minus alpha log alpha. Now in the left hand side we can also write by the property of, now suppose that this is the equation 5 here. Here the integration constant is C2. C2 is the integration constant. Here C2 is the integration constant. You can see here this C2 is integration constant. Now we suppose that this is 5. Now we find value of integration constant C2. Now we find here value of integration constant C2. Now we find the value of integration constant C2. For finding this, we put here alpha is equal to 0 in given definite integral 1. We get I is equal to 0 because tan inverse 0 is 0. Now we put alpha is equal to 0 in 5. Put alpha is equal to 0 in 5. We get I is equal to here pi by 2 beta log beta plus C2 here, and you can see here when alpha is equal to 0, I is equal to 0, when alpha is equal to 0, I is equal to pi by 2 beta log beta plus C2. So put I is equal to 0 here. So 0 is equal to pi by 2 beta log beta plus C2. The value of C2 is minus pi by 2 times beta log beta. You can see here we find value of integration constant C2. Now we put value of C2 is in 5. So we get I is equal to pi by 2 alpha plus beta log of alpha plus beta minus alpha log alpha minus pi by 2 beta log beta. We put value of C2, that is the integration constant. You can see here this pi by 2 is common here. So we take pi by 2 common here. We write alpha plus beta log alpha plus beta, and we take common minus here. So this can be written alpha log alpha plus beta log beta. Now we use property of log in the right bracket. So this can be written as I is equal to pi by 2 log of alpha plus beta whole power alpha plus beta. Similarly, this can be written as log alpha to the power alpha multiplied by beta to the power beta. These are the properties of log. Here alpha log alpha plus beta log beta can be written as log alpha to the power alpha multiplied by multiplied by beta to the power beta. Here again we use property of log m minus log n, that is log m upon n. So this can be written as I is equal to pi by 2 log of alpha plus beta whole power alpha plus beta divided by alpha to the power alpha multiplied by beta to the power beta. So you can see here integration of tan inverse alpha x multiplied by tan inverse beta x divided by x square dx. This is equal to pi by 2 log of alpha plus beta whole power alpha plus beta divided by alpha to the power alpha multiplied by beta to the power beta. This is the value of the given definite integral. Thank you.